Uh, Second video for our cost distance tutorial class. Give you a funny little anecdote. My mother-in-law is fortunately here helping take care of Dez, as my wife's also out of town. I made the very foolish mistake of walking downstairs to try to say hi to him, and now he is screaming uncontrollably. I feel really bad for my mother-in-law. So if you hear any kind of baby screams in the background, my bad. All right, so the first video, the cost distance, right? We introduced this concept of cost distance runs on what would be called a cost raster. And, if Euclidean distance, for example, is beneath the surface, we don't see it, it's invisible. But there's a cost grid. It's like a toll or a charge that you're levied for every cell you would want to cross. That is a uniform value in Euclidean distance. It's a 1. There is really no charge. The only charge to pass through an area in Euclidean distance is the distance that you would have to traverse. And that's why you get maps like this, right? If the cell size was 1 foot, it would take 1 foot to get there, 2 feet to get there, 1, 2, blah, blah, blah. The primary difference is that cost distance allows you to manipulate this, right? It allows you to manipulate that underlying cost grid to have one of your own that gets applied to each cell. And this cost can be many things, right? It could simply be like we did in the first example. We retained that value of 1, yet we simply removed some things. We made some things no data, like you couldn't even pass them. So we still retained the distance algorithm of Euclidean distance. We simply removed some things from consideration. That's a pretty common use of this tool. Like you might actually have a map of all the roads or sidewalks in an area, and then you turn that into a raster, um, and then measure distance, but only allow them to walk on sidewalks and not streets or buildings or something, right? So it's not like you're adding a different cost for each cell. You're simply saying don't walk on some, walk on others. Other instances, you can actually manipulate the cost so that, for example, like this is just made up numbers I made, but I pretended that it cost 9 to get here or 12. And again, that cost can run the range from very tangible, like seconds, right? That's what we're going to do in the next example. It's a very common use of this. But it could also be intangible, like risk that my ex is going to see me, or opportunity for something to happen, or number of people that a zombie might eat. But it remains proportionally linear no matter what, right? So if I put a 9 here, it's going to multiply that cost by 9. If I put a 12, it's going to multiply it by 12. And so that's how it happens, right? If I have a cell size of 1 foot and I start here, to get to this cell, which costs 9, right? That's how much that cell's charging me to pass through it. It would be a value of 9 because that's my first cell. Then to get to this cell, which charges me 12, well, I have my original 9 that I got getting here, and I've got to add another 12 to it. Yet if I went away like this, right, the cost is much lower. I can get to an area that is farther away, right? As you can see, it's farther away than it was on the original map. But if I take this route here, I only accumulate 5 things, right? 1, 2, 4, 5. That is cost distance. So what we're actually going to do is play around a bit with this, and maybe we'll actually transform this into a grid of time. And I want you to do it in a really cool way, a skill we didn't learn too much about, but it's always helpful. I want you to add a field and call it speed. It's very important. I want you to make this a float or a double. Give it 9 and 5. And then I want you to right-click on Campus Combine and go to Edit. So we're actually going to edit this in such a way that we're going to give them values. Now, I did a little Googling. Found like the average walking speed is 3.1 miles an hour. Did a little calculations and found out that 3.1 miles an hour roughly translates to 0.2199 seconds per foot. So essentially, I'm going to start giving a cost grid where that's the charge to pass through cells, 0.21. That's how many seconds it would take you to get across a grid. And then if it's a 1 foot, it would take you 0.211 seconds. If it's 2 feet, it would take you 0.42. If it was 3 feet long, it would take you 0.6. That's how you get up to that walking speed. So I want you to come in here and select paths, crosswalks, and sidewalks. So all the crosswalks, the sidewalk, and the paths. Right click where it says speed and go to 0.2199. And just because we're playing around here, I'm going to pretend that it costs more to walk on the land. Let's say it costs 0.5. And I know it probably, doesn't, but to just show an example, let's pretend maybe it's like the dead of winter and there's a lot of snow. And so, on average, it would probably double your travel time to walk through the grass because you got to like navigate the snow and stuff. So we'll make it 0.5. And let's say to walk on a driveway, it's 0.4, just because, you have to have that extra, little time to look around and make sure you're not going to get hit by a car or something. The other three I'll leave 0, or the other two, buildings and streets. And what I want you to do now is just select buildings and streets only and go to switch selection. So click editor, save your edits. You might have to reselect after you save your edits. All right, so buildings and streets, there's no, we're not even going to include them, right? We're selecting them out. And everything else I've given a value of either 0.21194, or I've given a value of 0.5 if you're land or 0.4 if you're a driveway. And in order to traverse this and create this into like our cost grid, there's actually a neat little tool under Spatial Analyst reclass called Lookup. And it works very similar to a reclassify, but it allows you to handle non-integers. So one of the flaws of reclassify is you can't turn something into a float. I'm not sure why it is. It's just kind of like a little arc flaw, but you can do it here. And essentially what you're saying with the lookup tool, if we drag in Campus Combined, and we say our lookup field is speed, it's going to do an automatic reclass for us, but that's going to take these values. So what we're going to come back with is a grid that has 3 values, 0.2199, 0.4, and 0.5. It doesn't matter that one is one crosswalk and one is another, land or driveways. All that's going to matter is the speed, right, the seconds that it takes us to cross that piece of land. And so I'm going to name this one seconds because that's going to be our second cost, right? Because it's our cost is now going to be in seconds. And the cool thing with raster, like anything in ArcGIS, as long as something's selected, right, it's only going to do what's selected. It's a bit of a misleading symbology. If you go to properties, go to symbology, and just do unique values, you'll see that there is, in fact, only 3, right? And maybe I'll even make them look like I don't know, like a dark red, do a light red or something. Invert those colors, right click, flip the colors so that I know that it cost me less in terms of seconds to walk on the paths, and then it cost me second less to walk in the driveways, and then it cost me the third least distance to walk on or the third most distance to walk on the grass. So now we've got our totally new grid, right? It is a cost grid, and the charge is seconds. So it's essentially telling you this is how many seconds it takes to walk on me as a cell. And the idea would be that like the shortest distances would be areas that are following the pathways, right? To get us from where to where. All right, so we still got our origin point here. Come on over into the distance. Come on down to cost distance. Drag in your origin point. Drag in your new cost raster in seconds. And we'll call this one seconds to travel, if it'll let us. Oh, too long. How about seconds to trav, right? It's essentially telling us the seconds that it takes to traverse. So it's going to do its thing, right, running its calculations. Right, a map that is now totally different, right? The answers that come back to us are nothing like the answers, or sorry, the numbers that come back to us are nothing like the numbers that we had before, because we're no longer measuring this in terms of oops, sorry. All right, we're no longer measuring this right in terms of distance. Now it's actually seconds, and that's why you don't have the like I think it was like 4,000 or whatever were the distances that we go to, right? You have a maximum of 1,810 seconds. And it's kind of neat, right? We can actually see this taking effect, right? So if I zoom into a map here, right, I know that I started at this kind of blue point. And you notice my map kind of goes like this, right? It follows this kind of interesting path where it starts to veer about getting more difficult as you get away from this central area here. And the reason that is the case is because if I go below me, that's where the path is, right? The path is leading right down that area. So if I were to look at two areas, you know, like here, for example, here and then maybe here, which appear to be equidistant from one another. Here, it's like almost 300 feet away, and here is about 300 feet away. But if I look at those two in terms of the cost, how many seconds it takes me to get there, right? To get there, it takes me roughly 213 seconds. So, you know, about roughly around 3 or so minutes. But to get here only takes me 100. And why is that the case? Well, because the model that we set up, it costs more to just walk away from the paths. You can't go through buildings. So to get there, right, not only have to walk through paths, but you'd either have to keep going this way, or you risk the extra time of trudging through the snow, right? It's kind of hidden behind an area. Versus that place here, I'm nice and clean. I can walk on my nice paved paths and get exactly where I need to go. So that's cost distance. That's essentially what we've done. We've made ourselves a new map here, which shows us in terms of seconds the minimum number of seconds it estimates that it would take you to get to each of the cells. So for the second video, what I would like you to do is run this process to create your own cost grid that is the seconds of travel, and then to create the ultimate resulting cost distance that shows you the number of seconds it would take you to come from the origin point onward.